Hey guys, this is Coach Lowe, and we're going to talk about the WIC that you guys went through last week. So that stands for What I Know. And so here's the one that we looked at. Get to the top. There's the What I Know that we looked at on 8:30. And so I'm going to do short little videos on numbers 1, 2, 3, and 4. So you can fast forward through this and take whatever you need out of it. So let's look at number 1. I can make generalizations about the resulting graph when arithmetic operations are performed. So remember, that means when you add or subtract or multiply or divide functions. So I gave you two functions. When I add two functions together, so let's say that I add 2x squared plus 4x minus 1, and let's say this is f of x, and I add that to g of x, which is negative 7x plus 3. When I add two functions together, remember we're going to add like terms. So my exponents, whatever my highest exponent is, that's the highest exponent that the resulting graph will be. So if I'm adding or subtracting these two functions, my resulting function will be exactly what this exponent is. So I know that this is a quadratic function and that this is a linear function. I know that because the exponent here is 1, which makes it a line, and the highest exponent here is a 2, which makes it quadratic. So now when I combine like terms, so I have 2x squared plus, no x squared over here, so I just have 2x squared. And then I'm going to add the 4x, positive 4x, and the negative 7x. So 4 and negative 7 is negative 3x. And then the negative 1, or the minus 1 plus 3, makes a positive 2. So my new function, and you can check it on Desmos if you'd like, but my new function is still a quadratic. Even if this g of x had been a quadratic, my resulting function would have been quadratic. So think about that for just a second. Even if I had said 3x squared here, that would be okay. It's not going to change the power. It will only change the coefficient here. So instead of a 2 here, when I add these two guys together, what would it be? Yeah, 2 plus 3, it would be 5x squared. So again, the resulting graph would be quadratic when I'm adding or subtracting. Now the ball game changes when I start multiplying. All right, so notice these were different functions than the ones that I gave you. So these two started out linear, so guess what this one's going to be? When I add f and g together, yeah, it's going to stay linear. All right, so let's look at the second one. What would the graph look like if we multiplied them? Well, let's go back to ours that we've set up here, and I'm going to go ahead and take out this 3x squared, and I'm going to remove this 5. And let's call this one j of x, and let's look at multiplying these two guys together. So just a little reminder, when I multiply f and g together, and this would be true even if we are subtracting, we would want to use parentheses. With addition, it's commutative, so it doesn't matter what order we add in, so we don't have to have those. And the subtraction sign, you know, you're subtracting each of those items that are in the second polynomial, so it does matter on that. With addition, it doesn't. Multiplication, it is also commutative, so it doesn't matter if I put this guy in front or this guy in the back, it's totally fine. But I do want some parentheses here, because when I multiply each item or each term that's in this first one has to be multiplied by each term in the second one. So I want to make sure that I keep good track of this. So I multiply here, which 2 times negative 7 gives me negative 14, and then I see the x's, and so I have x multiplied by, let's see if I can get rid of this guy right here. Come on, go away. Hold on. There he goes. All right, so I have x squared multiplied by x, which gives me x to the third. So remember, when I multiply, add my exponents, and I'll get this guy right here. So 3 multiplied by 2 is a 6, and x squared. All right, so there's my first two. Now I'm going to move, and I'm going to grab this guy right here, the positive 4x, and I'm going to push it through to the second set of parentheses. So I've got 4x multiplied by negative 7x, which gives me a negative 28x squared. Remember, adding those exponents, and the exponents on these guys are both 1, so I want to be careful there. And then 4x times 3 is a 12x. And now I'm going to take the -1 and I'm going to push it through to everything over here. So I have -1 multiplied by a -7x, which gives me a positive 7x. And a -1 multiplied by 3, which gives me a -3. All right, so I can go ahead and combine my like terms. I see that I have an x cubed, and that's the only one, so I'm going to go ahead and write that guy down. I see I have x squared here and an x squared here, so I'm going to go ahead and put those two guys together. So 6 and -28 is -22x squared. Then I've got my x's that I'll put together, and that makes 19 of those, and then the 3 is by itself. Notice I have moved from a square function, a quadratic, to a cubic function. So now my graph will look like this. We will talk about those next week also, but my graph changes shape. It's no longer cubic, or it's no longer quadratic, no longer a U-shaped graph. I've moved to a cubic function. That happens when you multiply and divide. Those graphs can change shape. All right, so that's the first question. Can you tell what those graphs look like? All right, let's look at the next I can statement. So one of these was I can perform operations on functions when I'm given a table or an equation or a graph. So we perform 2 operations back here, so you can use those 2 for that first one also. And then let's talk about off of a table. So if I ask you to find f of x, which I'm going to define as g plus h of 3. All right, so I want you to find the f function, and the f function at 3, so we'll say this is also at 3, is g plus h at 3. All right, so what does that mean? Well, I see my x column here. This gives me all the x values, and I see that 3 has taken the place of x. So I'm going to go to 3, and I'm going to target the y values, because that's exactly what this means. Go to the g function when x is 3 and find out what y is. Go to the h function at 3 and find out what the y is, and then add those guys together. So another way to write this is this. So I have -4 plus 2, and that's a -2. All right, so you can practice on these. You can multiply, you can divide, you can subtract, you can take different values of x. You can find g minus h of -1. You know, a lot of different things you can practice on with this. So have fun with that, but that is exactly how you read that table. All right, let's look at the next one. This is number 3. I can add, subtract, multiply, and divide functions. All right, so we did adding and multiplying on the last one. So let's look at subtraction, and then we'll also talk about division. So let's look at f minus g of x. So this is the second one that we're looking at right here. So this means f of x minus g of x. So I'm going to replace f of x with the information that they've given me. Now on yours, this is a little squared guy, and this is a squared guy. So know that those are supposed to be exponents. So I have -2x squared minus 8x plus 4. That's f of x. And then g of x is 9x squared plus 6x minus 2. All right, so I want to shove the subtraction sign through though. So I have plus, and then everything in here is minus. That's because you're subtracting. So I have -2x squared minus 9x squared, -8x minus 6x, 4x minus a -2x, which makes that plus 2. That's why we're pushing that subtraction sign through, because we have to subtract every single term that's over here. All right, so let's look at that now. All right, so -2x squared minus 9x squared minus 8x minus 6x, or you can say plus a negative if you would like to, and then plus 4 plus 2. So notice, I see that I'm adding, so I'm pulling these terms. So again, if you want to say plus a negative, you can totally do that. And then -8x plus a -6x, you can totally do that. All right, so let's put these like terms together now. So I have -11x squared, and I have a -14x, and I have a positive 6. All right, another way to do it now that you have a plus sign here is just drop the parentheses and put like terms together. And so again, we would have -2x squared plus -9x squared, which is exactly what we have here. And then I would say -8x plus negative 6x, which is exactly what we have right here. And then the 4, positive 4, and now a positive 2, which is exactly what we have right here. All right, so lots of different ways to look at this, but this would be my new function, and we can call it h of x if you would like to. And there's my new function. All right, so the last one. Number 4, I can state the domain and range of any function using interval notation or inequality notation. All right, so I gave you a really weird graph on this one. I mean, it was super weird. So we're going to kind of look at that. So let me put some marks on here. We'll go out here to negative 5, and we'll go over here to 5, and I think yours went to maybe 6 or so. And then we'll come up here to 5 also, just for fun. And this down to negative 5. All right, so let's go ahead and draw a crazy graph in here. So we're going to start it right here at negative 5, and let's just swoop this guy down. Let's go to about right here. And I gave you some open circle things, and then it has some closed circle things, so it looked really odd. All right, so let's talk about this. Okay, my graph actually stops right here. So when I'm talking about domain, I'm looking at taking everything back to the x-axis. So I see nothing is over here. There's nothing that goes past negative 5. So I know the furthest over to the left it's going to go is negative 5. Now, I see a hole here. Okay, that means negative 1 is not in the domain, but I look up here and hey, I can draw that right back to the x-axis. So I can draw back to the x-axis here, and I could draw up to the x-axis here, but I can't right here, but this graph picks it up. So now I'm drawing back to the x-axis here, but oh, I have a hole right there. But look at this guy. It lets me draw back to the x-axis, and then I continue to draw back to the x-axis, and that has an arrow on it, which means I just continue drawing. So it goes all the way to positive infinity. Okay, so this is interval notation. Inequality notation would look like this. And then we're going to go all the way to infinity here. All right, so there's no stopping point there. All right, in fact, we could just say, we don't really use infinity on that, we could just say x is greater than or equal to negative 5. All right, so once you write it in interval notation, you go, oh, well, there's an infinity here. I need to switch this around because this means I can use anything to the right of negative 5, which is exactly what this says. I can choose any x greater than or equal to negative 5. All right, let's talk about range now. So range means how high and low this guy goes. All right, so now I'm drawing back to the y-axis. So this thing is going to bottom out at negative 5, but notice there's an open circle here, which means negative 5 is not included in the range. So I use a parenthesis to show that negative 5 is not included in the range. Now let's see how high this guy goes. So I see that there's a hole here, but it's included because I can draw it back here where that hole was. And then I move all the way up, and I see this is just going up and up and up. So as I draw back to the y-axis, I continually draw back, which means this guy goes to infinity also. All right, so that means when I write it in inequality notation, I have, y, not x, y is greater than negative 5. Not greater than or equal to because negative 5 was not included. All right, guys, hope that helped and made sense, and I'll talk to you guys soon. This is Coach Lowe, and I'm out.